All right, let's look at example 3 from chapter 2, section 5. And we are looking at even odd functions and the possibility of being neither. So let's look and see what we get here. So notice we have the definition on the bottom. And both for even and odd functions, we start out with the function f of negative x. So we just want to figure out what sort of result do we get from f of negative x. So we'll look into that. Okay, so for a, we have f of x equals x cubed. So we're going to look at f of negative x and compare that to x cubed in the end. So we have negative x cubed. That's equal to, now that's negative x times negative x times negative x. So negative x times negative x is x squared. Then x squared times negative x is negative x cubed. So what we notice is that this is equal to, notice that x cubed is f of x. So we actually have negative f of x. So f of negative x is equal to negative f of x, for this case, a. So by definition, this is an odd function. As you can see, this is what we have, an odd function. So this is an odd function. Okay, moving on, we have f of x equals absolute value of x. Oh, we want negative x. Again, we want to plug in negative x. And we want to see what that result is and compare that to absolute value of x. So we have negative x. We're going to take the absolute value of that. But we know that the absolute value of negative x is equal to the absolute value of x. Just guaranteed. And you can plug in a few numbers to check this, but imagine if we plugged in negative 2. That's the same thing as the absolute value of 2. The absolute value of positive 2 is equal to the absolute value of negative 2 either way. So this will always be true. So notice that the absolute value of x is f of x. So f of negative x is equal to f of x. So in this case, we have an even function. By definition, this is an even function. All right, so lastly, we have h. We'll look at h of negative x. This is equal to negative x to the 4th power plus 2 times negative x. Simplify this. And negative x to the 4th power will end up being just x to the 4th. You can check this similarly to what we did here. You'll notice that the negatives will cancel out. You'll just have x to the 4th. And 2 times negative x is minus 2x. So notice here that, that comparing x to the 4th to this term, it's the same term. So just by looking at this first term here, x to the 4th, it's the same thing. So it looks like it may actually be even, since it's not the opposite. It's not the opposite term. But notice that we have plus 2x and negative 2x. So if you look at the second term, it looks like they're the opposite. In this case, we have an odd function if we look at the second term. So the first term appears to be an even function, and the second term appears to be an odd function. So in this case, it's neither. You have to have all the terms be opposite or all be the same sign. So this is neither. So hopefully that makes sense. Let me know if you have any concerns about this process. The idea is you're plugging in negative x to the function and seeing what you get out and comparing that to the original function and seeing if you have the same function or the opposite function. So even or an odd function, or it could be neither. So hopefully that makes sense. Let me know if you have any concerns. I'll be more than happy to help.